Today's lesson will be very, very similar to the previous lesson where we talked about arithmetic sequences and series. But today we're going to talk about geometric sequences and series. So our objective will be to identify a geometric sequence, find an explicit formula for its nth term, and write a recursive formula for them. These are the same sequences that we dealt with last time, but just to review these, this first one is starting with 2 and it's going up by 2, and we keep adding 2, so this would be considered an arithmetic sequence. And if you remember, we could find a formula for this. That formula would be, using the trick, it would be 2n, because d is 2, and then the 0 term would be 0. So 2n plus 0, which is just 2n. Then if I wanted to find the 10th term, I could just put 10 in for n. The 10th term would be 20. If I wanted to find the sum of, let's say, the first 10 terms, remember that would be 10 divided by 2, and then the first term, which is 2, plus the 10th term, which we found to be 20. So it would be 5 times 22, which is 110. And that is just a review now of what we did with arithmetic sequences. The second sequence, we're multiplying by 4, it looks like. So this would be called a geometric sequence. And we're going to talk about that in much greater detail, and you'll be able to do some of the same things we just did for the arithmetic. The third one here, we're going down by 3. So it's like we're adding a negative 3, same as subtracting 3. So this is an arithmetic sequence. So once again, just as a review, the formula for this one would be, using the trick again, the d is negative 3n, and then the term before the first would be 18. I could ask you to find the 5th term, put 5 in for n, that'd be negative 15 plus 18, which would be 3. If I wanted you to find the sum of the first 5 terms, it'd be 5 divided by 2, half of 5. First term, which is 15, plus the 5th term, which is 3. So it would be 2.5 times 18, which I believe ends up being 45 as your sum of the first 5 terms. The next one here looks like a combination of things. We're doubling and adding 1, doubling the number before it and adding 1. This is neither arithmetic nor geometric, and we would only use a recursive formula to write this. And the last one, we're squaring the number and adding 1, and that again would be neither one of those sequences. So, getting into the geometric sequences. A geometric sequence will have a common ratio. Remember, the arithmetic sequences had a common difference. So the ratio is just what you are multiplying by each time. So for example, the 2, 6, 18, 54, what are we multiplying by? It looks like we just keep multiplying by 3. So the ratio would be 3. 4, 6, 9, 13.5. Some of you might look at that and say, I don't know what they're multiplying by. But you can always do this. Just take any term, divide it by the term before. 9 divided by 6 is 1.5. If I took 6, I divide by 4. That's still 1.5. That means my ratio is 1.5. Very easy to find what the ratio of a geometric sequence is. Just divide 2 consecutive terms. The next one, the sequence of 2/3, 4/15, 8/75, would have a common ratio of 2/5 because you're multiplying on the top by 2 and on the bottom you're multiplying by 5. The explicit formula for the nth term of a geometric sequence. If you just think about what they're doing, we're going to start with the first term, which is g sub 1. We used a sub 1 before. It could be t sub 1, that doesn't matter, but that is the first term. And then what are we going to do? We're going to multiply by r, that's our ratio. If we're finding the fourth term, we would multiply by r 3 times. So that power is n minus 1. So for example, one of the sequences above was 2, 6, 18, 54. This formula would be g sub n would equal 2, the first term, times 3 to the n minus 1 power, because 3 is the ratio. The sequence 4, 6, 9, 13.5. The formula would be first term, which is 4, times 1.5 to the n minus 1 power. Here's some more examples of geometric sequences, just practicing those formulas. This would be first term, which is 5, times 2, because 2 is the ratio, times n minus 1. This next one looks like we're cutting everything in half. We're dividing by 2. But we're always going to think multiplication. So in this case, your ratio is a half. You're multiplying by a half. So the formula would be 50 times 1/2 to the n minus 1 power. This next one, if you think it's geometric, take 5.4 and divide by 3. Or 9.72 divided by 5.4. And I believe you get 1.8 in both cases, which means it is geometric. The formula would be 3 times 1.8 to the n minus 1 power. If I asked you to find in any of these sequences like what the 8th term is, g sub 8, you would just put 8 in for n. So in this case, you would take 5 times 2 to the 7th power, or 50 times 1/2 to the 7th power. That power will always be 1 less than the term. That's going to wrap up this video, and there'll be another video talking about the sums of geometric sequences.